Have you ever felt overwhelmed by the sheer number of options in software development? Maybe you're building an app and get bombarded by 100 different ways of how to achieve good logging, each claiming to be the best. Or what about database connections? Isn't it crucial to only have one for efficiency and to avoid resource overload? This is where the Singleton pattern comes in. Let's call it a secret handy weapon, or a handy secret weapon, to achieve clean and maintainable code within a single point of control. Hi, my name is Gene, and welcome to my first video on this channel. Let me tell you what we will be talking about in this video. First, we'll dive into the basics of the Singleton pattern, and then we will apply our knowledge and create ourselves an example in Java. And as we're basically talking about object orientation, we can apply the same knowledge in any object-oriented programming language. So let's also create an example in Python. After that, we will talk about a couple of things to take care of when making use of the Singleton pattern in Java. Those topics are a little bit more advanced, but more on that later. Let's take a look at the structure of the Singleton pattern. What we need first is to create a class, and for this example we will make use of the name Singleton. Every class has a special method called a constructor, and this constructor is used to create an instance. Usually this class is public, which means that it is accessible from the outside. In this case though, we don't want that. So we set it from public to private. Private meaning that it's only possible to create an instance from within the class. But since we still need to create an instance of our Singleton class, we create ourselves a method called getInstance, which returns the type of the class itself. In our example, the Singleton class. Now, we still need to remember when we created an instance. And for this, we create ourselves a local variable, we call it instance, of the type Singleton, which is the same that our class has. The local variable, instance, needs to be private as well, because we don't want it to be accessible from the outside. One thing stands out a bit in the structure, and that is that both the method getInstance and the local variable instance both need to be static, because we don't want it to be part of the instance. We need it to be part of the class instead. Okay, so let's build the Singleton pattern in Java. So the first thing that we need is a singleton.java for our Singleton class. And we create a private constructor, Singleton. As we cannot create any instance from the outside now, we need a possibility to create one from the inside. To do this, we need the getInstance method, public, static, because we want to have it stick to the class and not to the instance, returning a Singleton, and we call it getInstance. And now we want to check whether we have an instance or not. And for that we need the variable, private, static, because we want to have it stick to the class and not to the instance, Singleton, and we name it instance. Now we can check it. If instance is null, then create a new Singleton instance and return the instance. That's basically all we need for the Singleton pattern. But we also want to test our Singleton. So for that we want to be able to store a message. So private, not static, because we want to stick it to the instance and not to the class. String message. And now we need a possibility to set the message. Public, void, because we will not return anything. Set message, string message, which will set the local variable message with the argument message. Now we need a possibility to show the message as well. And for this, we will create a method public, void, because we will not return anything, show message, and we will print it to the terminal. System out print line this message. That's all we need for the Singleton class. And what we need now is a main class to create our tests. Main Java. Here we need to create the standard main method public static void main takes an argument of string array, which we will not need though. Okay, so what we will create now are two variables, s1 and s2, and both variables will request an instance of the singleton class. So singleton s1 is singleton get instance, and the same thing for s2 gets its instance here. And we now want to check whether it is really the same instance. So let's create a terminal output for that. System out print, not with a new line, same instance in S1 and S2. And here we create the test itself. Out print line, this time S1 is S2. What this returns is a Boolean, either true or false. And obviously in this case it should return a true because S1 and S2 should have the same instance. What we will do now is set the message in S1 and then output it in S1 and S2. It should respond the same message, right? And then we will test the same thing with S2. So S1 set message, hello S1. And now the output, S1 show message and S2 show message. And now we repeat the same thing for S2, hello S2, S1 show message and S2 show message. That's all we need. What we want to do now is build and run the application. For that we need a manifest file. Manifest.txt. What we want to do here is tell Java what class to run first. So main class, main. Now there's one thing that's very easy to miss here, and that's the carriage return. Say we didn't do that, it wouldn't run the application correctly. So that's very important. All right, what we need now are build scripts. So one for Windows, build.cmd, and another one for Mac and Linux. Build. So the build.cmd starts with echo off. Create a class file for every Java file that you find and pack everything into a singleton demo.jar. jar cvfm singleton demo.jar. First the manifest and then every class file that we've created before. So this is the script that we run when we are on the Windows. If we are on Mac or Linux, we run the bash script. It's very similar. The only thing we really need to change here is that we address it to bin bash. That's about it. Now we need two more scripts for running the application. So let's call them run.cmd and run. The run.cmd starts again with echo off and then Java run the Java singleton demo.jar. For Linux and Mac it's very similar again. The only thing we need to change is that we address it to bin bash. Now for Linux and Mac we need to provide execution rights for the scripts. And that's done very easily by using chmod plus x for build and for run. And there it is. Now we have execution rights for run and for build. And that's it. Now we can build and run the application. So let's do that. Build and run. Okay, so now we have our input. So yes, indeed, it was the same instance. We first set S1 to hello S1 and created an output for S1 and S2. And then did the same thing for S2 and created again an output for S1 and S2. And we can see here that we were always in the same instance because every change in the set message affects both S1 and S2. Okay, let's take a look at the singleton pattern in Python. The first thing that we need is a singleton class. So this we will put into a singleton.py file. Class singleton. In contrast to our Java example we did before, our approach in Python is slightly different. We will not need any getInstance method. Instead, we can use one of Python's class methods called __new__. Define __new__, and here we have the parameter for accessing the class. The next step is to check whether the instance already exists. And for this, we need a local variable, instance, that we set with none. Now we can check whether the instance exists. So if cls._instance is none, if that is the case, then create a new instance, call the superclass __new cls. Once we're done, we return the cls._instance to the caller. So that's already all we need for the singleton pattern in Python. Like in the Java example before, we will implement the possibility to store a message. For that, we will first create an instance method to set the message. Define set message, self, and the message. And in here, we access the instance self._message equals to the parameter message. Now we need to show the message. Def show message self, and in here we want to print the message to the command line ._message. That's all we need for the singleton class. What we need now is a main.py to create our test cases. So the first thing that we do is import from singleton, import singleton. Here we do not need a class, we can start with the function right away. Main, and like in the Java example, we will create ourselves two variables, s1 and s2, that each call an instance. s1 singleton, s2 singleton. Now we can check whether the instance is the same. Print same instance in S1 and S2. We do not want a new line, so we set the end to empty. And then we print S1 is S2. Obviously, as we expect the same instance, it should result to true. So the next thing is that we set the message in S1, hello S1, and then, like in the Java example, we show the message in both S1 and S2, and then we repeat the process for S2, set message, hello S2, and S1 show message, S2 show message. Now we need a small code section to ensure that the main method is only executed when the code is run directly. If __name __ equals __main __ main. That's it. We're done with the coding. The only thing that remains is that we create ourselves a run script. There's no need to compile anything in Python. Running directly suffices. So let's create a run.cmd for Windows and a run for Mac and Linux. Okay, let's start with the run cmd with an echo off, and then we address Python with the main.py. The run for Mac and Linux is a bit different. First we address bin bash, and then we address Python 3 main.py. Now we need execution rights for the Mac and Linux run. chmod plus X, give execution rights to run. Check. And there we have it. We have execution rights for the run script. And now we are ready to execute the run. So run, and the result is as we expected. S1 and S2 have the same instance. Then when we set the message in S1 and output it for S1 and S2, we get the same message for both. And when we set the message in S2 and then show the message for S1 and S2, we get the new text, hello S2. Quick question. Have you ever used the Singleton pattern in your projects? If you have, drop a comment below and let me know where you used it. I'm curious to see where others put it to work. Also, if you prefer reading the content at your own pace, I've got you covered. All the information you're seeing here is also available on my website. You can find the links below this video. But hey, I'm glad you're here. It's always fun to interact and explain things visually. Okay, let's talk about a couple of topics regarding the Singleton pattern in Java. The first one would be multi-threading, and in this specific case, it would be the Singleton class being accessed by multiple threads at the same time. Though this may run into competition errors. And frankly, there's no way to know what thread is accessing what line of code. Let's take a look at the getInstance method that we had before. Imagine you have two threads running at a very similar time trying to access the getInstance method. Take a look at this little code fragment. We have the getInstance method that we first use to check whether we have an instance or not. And if not, we create a new one. And then after that, we return it. If we have the thread 1 trying to access the getInstance, then we have the thread 2 accessing this method at the same time. And the third step, thread 1 checks whether the instance is null. And the instance is still null, so if returns true. In the fourth step, thread 2 also checks whether the instance is null. And as the instance is still null, if returns true. Now in step 5 and 6, both threads 1 and 2 create an instance of the Singleton class, and this results in an error because thread 1 will save the instance in the variable instance, and thread 2 right after that will create a new instance and save his instance in the variable instance. Meaning that thread 1 and thread 2 do not have the same instance now. One solution to this problem would be to use the keyword synchronized. Now, having this in place, threads will have to wait for each other, meaning there is no competition anymore. There's a problem with this approach though. Waiting threads are idle, and this results in performance issues. A solution to that could be changing from lazy to eager initialization. What this means is that we create our instance directly in the static instance variable. This also means that we do not need the overhead for checking whether the instance exists or not in the getInstance method. But with this approach, there's also a problem. The instance creation is done even if the instance is not needed. And the solution to this is to keep the lazy initialization and implement double-checked locking. So now we re-implement the instance check in the getInstance method, and we also add a second instance check, including a synchronized block. Okay, so let's walk through that again with the thread 1 and thread 2. In step 1 and 2, both threads enter the getInstance method. Then in step 3 and 4, they both check whether the instance exists or not. And as the instance does not yet exist, they both get true and go to step 5 and 6, where they encounter the synchronized block for the Singleton class. Here only the first thread, meaning thread 1 will enter and thread 2 will have to wait. In step 7, thread 1 will again check if the instance exists, and it does not exist, so he moves on to step 8. Here he will create a new instance and save it in the instance variable. After that he will move on to step 9 and 10 and leave the synchronized block. And now thread 2 is allowed to enter. In step 11, thread 2 checks whether the instance exists, and it does exist because thread 1 already created one, meaning that the if segment responds with false, and thread 2 will not create another instance and pursue with step number 12. There's one little keyword that we need to add to the static variable instance, and that is the keyword volatile. This is because Java has implemented a functionality called command reordering, and this could mess up our game. So volatile prevents the command reordering. There are things to say regarding reflection and the Singleton pattern in Java. So reflection is a feature in many programming languages. It allows to inspect and manipulate classes, methods, and variables at runtime. Reflection also allows access to the private constructor of a class. When using the Singleton pattern, this is not wanted though, because it allows to create multiple instances. As a result, this breaks the behavior, violating the intended usage of the Singleton pattern. There are things to say regarding serialization and deserialization in the Singleton pattern. So what is serialization? This is the process allowing to convert an object into a format that can be stored, transmitted, and later reconstructed into an object. When deserializing back into an object, the process involves creating an instance of that object and entering stored parameters. Now, if there are multiple objects, then multiple instances will be created. This violates the intent of the Singleton pattern because multiple instances are created. Alright, that's it regarding the Singleton pattern. There will be more videos like this on this channel, and I wonder what the next video will be about.